Hey, so in this video, I'm gonna go over a few different methods for achieving achieving a high poly mesh with the intention of using that mesh for normal map extraction. Um, I think this is gonna be mostly like kind of high level uh, talk where I don't go into like specific techniques or anything, but just to really just show the pros and cons on each. In this particular case, I'm starting with a mid poly blockout mesh, which is going to be the base for the the results for each of the iPoly methods. So I'm for the blockout, I'm starting with the 64-sided cylinder, and then I apply a bunch of Boolean operations. Um, I'm just gonna turn them on and off so you see the process. So I cut the side, and then I apply another cut with this box that has a little chamfer on that edge. Mm, oops. Never mind. Then I attach this side box there. I cut this side um, with a box that has a chamfer on those insides. So it's kind of feels like it's a mold in a way because you're getting rid of all of this area, and this is like this negative space that remains. Then in this particular case, I'm just performing an extension with the box that I had here, and in this case, in order to get the chamfer to align with the chamfer from above, I just um, I just copied the value from this chamfer, and then I paste it as an instance here. Um, so this chamfer right here, this the segments value, it's basically being copied from this chamfer here. So when you come to any checkbox over here, you can just copy the controller, in this case the segments, and then you can paste instance. That means that when you change in one of the value in one of the uh, models, it changes on the other as well. So for example, if I do this, it's changing on the other as well, even though they are two separate objects. Um, in this case, I'm just adding a chamfer box, so it's just a box with the chamfer modifier. Then I add a cylinder with a little chamfer at the bottom. And this is removing that bit on the inside. So for example, if I get rid of the chords, you'll see that this is removing material over there. Same with these boxes, which I think it's just one. Yes. Yeah, so it's just one box, and then I do a little symmetry on the X and Y, and then add a array modifier, and then I just put edit poly on top so that I can join these two boxes and these two boxes, so that instead of having another of these cuts over here, it's just like one continuous cut. And this creates that inset for that little piece over there. Same for here. And then this adds a little cylinder on the inside so that it's not visible from, so it stops being visible from one side to the other. And then this little section adds a little rib there. Like I said, this is just being done in one of the sides, so on this positive X, then you just like make it symmetrical, and for good measure I just add a weighted normals. So this was the blockout, the mid poly blockout that I did, and now let's say that you need to make a high poly because you want to extract normal maps. You have different methods for this. One of the methods that I don't think I'm going to talk about here, even though I made tests with that as well, is the bevel shader in Marmoset Toolbag, which is really good. It's quite fast if you use it. You can just like bring this model into Marmoset and you get fast results straight away. But in this particular case, I'm going to talk about making this in sub-D, and then I'm going to talk about the bevel method and the remesh. I I think it's really self-explanatory when it comes to when it comes to sub-D. You you essentially just have to add control loops uh, in the areas that you want to control the way that the mesh is gonna subdivide, and just make sure that you prevent pinching areas. That's when like the shading isn't shading like properly, so you'll have like these lumpy bits, these bumpy bits like in the surface shading that makes it look like something is not not right. I think every artist should know or should learn how to do subdivision modeling, because it's quite important to know how to redirect like the flow of edges and polygons, especially because it's very lightweight. When you turn off the turbo smooth, well, in this case turbo smooth, in other applications they have different names, but when you turn off the subdivision modifier, you have like a very lightweight mesh. I'm not sure how many tries this is, but let's see. Polygons. So the it's just like not even 3,000 polygons. Obviously, it's an n-gon. It's a polygon here, for example, even though it would be like two or three triangles. But in this case, it's less than 3,000 polys. It's if you want to share this with another artist in the when in the place where you work, this is quite useful because it doesn't require like any specific plugin or any of this stuff. You can just turn off the subdivision modifier and you just like export this mesh, and then the person that's gonna take this over can just apply the subdivision in their modeling software, and everything is gonna look exactly the same as in your modeling software. So in terms of being able to share this between artists, it's quite good. It's quite good. I think the only downside is that this is quite time consuming. Um, the blockout was actually much faster to make than the conversion from blockout to subdivision modeling. I uh, I actually recorded the process when I did the subdivision modeling, and it's around like 2 hours. Uh, like just going over everything, cleaning up the booleans, like the vertices that you get when you perform like these boolean operations, and then you have to constantly toggling on and off the subdivision modifier to make sure that the surfaces are shading in the exact way that you want. And it's 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 time consuming. I think unless you have like a very good reason for wanting to model something in subdivision, there's probably like faster ways to do the same thing. So I think this took roughly around 2 hours. Um, but yeah, like I think if you're starting, definitely learn how to properly use subdivision, because it's not just about being able to clean up, uh, you know, mid-poly models in order for them to subdivide well. Sometimes, even if you're trying to make something with Dynamesh, you still need how to, excuse me, you still need to know how to make certain parts in subd, because you're gonna want to make the 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 base model with subdivision, and then use booleans to cut things out. The other method that I made was with the bevel modifier. Oh, this is interesting. I didn't know that I collapsed this. Interesting. This is something similar to the subdivision method. The only difference is that you're just using the chamfer modifier uh, the chamfer modifier to get the nice hedge highlights on your model. Um, and the funny thing is that I'm not even using a subdivision um, modifier on the mesh itself. And this mesh itself, excuse me, I don't even think that's gonna work. Uh, well, I guess it does, but it has like weird kinks and things like that because the intention was never to put the subdivision on top. It was really just to get the the bevel on the mid poly, and that would be enough to get the shading on the edges uh, when you're extracting your normal maps. So let's say that the blockout is the low poly. When you create the Highpoly version with the bevel, then those sharp edges get these nice shading, which is the what you're gonna get on your normal map. It's just a shame that somehow I guess I ended up collapsing the modifier. Mm, but in any case, I would uh, maybe I did collapse the modifier when I was working on this because maybe there was some areas that needed like some shading adjustment. It's quite possible because I guess when you're doing stuff like this, you want to make sure that you're like redirecting the flow of edges so that the shading works to your advantage, right? So it's possible that you will always have to make some adjustments after you put the bevel modifier. Might not be so clear cut to get like a result that you like, but it's it's much faster than cleaning up the blockout for subdivision. Well, I guess I can show these pieces here. Okay, let's see. Okay, I guess yeah. So I put the bevel, the chamfer, and I guess there's these issues over here, which I suppose I cleaned up with the edit poly on top. Yes, kind of. But see, this is the type of stuff that there's always trade-offs with with any method. I suppose that if you're just working on like a prop that's not gonna be very, um, it's just like a world prop, an environment prop. This would be more than enough, the way that it looks. So I suppose that some of this stuff also needs to be taken in consideration, like the way that the prop is going to be used, because some methods they lend themselves better for certain situations than others. Just gotta figure out which one is the most suitable for your particular case. Um, the the next method and final one is the remesh, where I use the remesh modifier. And essentially, what I did was I made a copy of the blockout, and then I I increased the segments and the chamfer value. Well, segments, not value. I'm not trying to increase the radius of the chamfer, but like the number of segments, because that's the thing that's gonna drive the smooth result when you apply the remesh. So in this case, I it looks like this because I have the adaptivity set to 0.01. So if I turn this off and if I turn this to 0, it's going to go from 218,000 to 883,000. You stop having those kinks and all those things on the edges that you're going to see around here. But when you're like working on the model and cleaning up everything, I think it's reasonable to have something like this turned on while you're working, because it's much faster to turn on and off. It becomes much slower if this is always at 0. I only put this at 0 when the model is done and I want to export this to baking or to ZBrush for like further sculpting. But the way this works is just like in Blender where you have the remesh. You you have your model, and then when you apply the remesh, the voxel size controls the size of each square roughly. So if you keep turning the voxel size down, you're gonna get much smaller voxels. So usually what I do is I set my voxel size. There's a bunch of different filters that you can use. I tend to use the Gaussian, and I turn this to 0 as well. I add a Gaussian filter, which basically smooths out the mesh, and then when this is when I have this on, I keep tweaking the voxel size until I find something that I like. In this case, you're seeing the segmentation because it's essentially remeshing the base model. So if the base model isn't like smooth enough, like each of these faces, it's going to get voxelized the way it is. So if I turn this on again, excuse me, it looks like this. But if I change the number of sides to, let's say, 64, it starts to get much smoother. And it doesn't really matter if there's smoothing like on the faces or not, because it really just the modifier, the plugin only cares about distance between faces. So if I turn now this to 128, now it's very smooth. And then, for example, if you feel like you would want a bigger bevel here as a result, you can just like increase the voxel size. There's different ways. You can either increase this or you apply a chamfer. But really, at this point, if you're doing it this way, you might as well just keep this as your Highpoly. I think a particular way to show more about this result is that, for example, when you have a box like this, and then you intersect it, let's say something like this. You intersect it this way with this cylinder. Now if I turn on the remesh, I can essentially the voxel size is going to be the value that I want for the very sharp edge. So in this case, this 90-degree edge, I'm going to basically change this value so that this edge here has the result that I want. And then I'm not going to focus too much on this one, because if I want, I can just like change the roundness with the chamfer, and then it's going to roughly keep that curvature. And if you see, like at 0.01, you start to notice the segmentation again on the cylinder. So that means that you either increase the cylinder side segments, or you just do it like 64 and then you had a subdivision on top. See, this is the thing that I mentioned about um, being too slow when you're working. So it went from 1 million to 93,000, which is much more reasonable. So now if I put a subdivision and I turn on the smoothing groups, so now let's see, two iterations. I have the box here. So if I turn this on, let's say I want this to be a bit more wide. So I'm just going to put it 0.2. Okay, and then if I want this to be a bit like thicker, then I can just like bring back the chamfer. So now if I turn on the adaptivity to 0, then this is gonna disappear, and essentially you have your Highpoly. And to me, the ease of use, it's because you can just make like changes to your mesh really fast, and you can see the way that Highpoly is going to look like in the end. You don't need to spend hours making adjustments to the subdivision model. The only thing, for example, that I will say is that, for example, let's say that this is your model. You're quite happy with this. And then you wanted like these two edges to be much wider. So you can do something like this. And then okay, I want this to be aligned over there, so let me just do something real quick. I'm just going to extract a copy. So let's say something like this. So the only thing that becomes an issue is if you want to have a section of the model where you want the chamfer, the remesh to be smaller. So for example, I'm gonna make this copy. So if I subtract those three boxes here and then I turn on the remesh, this is the way that it looks. But let's say that you would want that detail to be like much sharper so that it stands out from the rest. The way that it can be done is to apply a boolean for the detail that you want a different voxel size on top. So I still have this as my base result, but then I will copy the modifier. I will apply a boolean and subtract this mesh that I just created. And of course it's going to take a little bit longer, but now if you paste the remesh and change the value to 0.01, everything is going to be similar to how it was before, but this new result is going to look much sharper. So it's almost like there was like orders of operation when this was being machined. This gets smoothed out in one go, and then when these edges here are nicely chamfered, that's when they use the machine to carve out these parts, and that's why it becomes like sharper. But that's why I like to keep this set to 0.01, because then it's much faster to work and iterate. As long as you know that this is the way that it's gonna look like in the end, then it's fine. There's nothing to worry about. And so essentially, for example, in this piece, it's like I mentioned, it's I just cleaned up everything. I have smoothing groups, turbo smooth by smoothing groups. I removed this part with a little boolean, and then I just remesh this. So let me show you how it looks without with this value set to 0. looks like this. And then you can have different values, different voxel size values for different types of materials. Um, and since this is a modifier, you can copy paste the modifier as instance from one part to the other. So for example, in this case, for the main plug, it's set at 0.15. Let's turn this to 0. And so if I was to copy this and then paste as instance, whenever I change the value here, it would change here as well. But I think this is something that should be done on per material, on a per material basis, because for example, I think this should be much more sharper. So if I make this unique and then I just bring this, if I delete the 5, then it becomes much more in line with what this type of material is supposed to look like. Not rubbery type stuff. Yes, so but essentially for me at this point in time it makes much more sense to use a method like the remesh as my main method of making high polys, because I can just quickly make a mid poly, make sure that everything is nice and smooth, apply the remesh, and then if I want I can just export this to ZBrush, and I don't need to Dynamesh in ZBrush because this is essentially just already has the result that I want. If anything, I can just like subdivide it once or so I have uh, more room to sculpt. And since everything is roughly the same size in terms of faces, that means that when you're sculpting, you're gonna get so there's a even distribution of polys. So when you're sculpting, you're gonna get you're gonna get a good result, which is not something. When I say good result is that you're not gonna get areas that are more dense than others, because it's essentially equally dense all over the place. But when you're using subdivision, ideally you should probably remesh or Dynamesh in ZBrush, because for example you'll notice that like these areas look way more dense than these areas where you have like these big faces here and then you got like small faces here. So if you're sculpting over this area and then you go over here, you'll notice that there's going to be like a smoother sculpting look in here because there's just more faces. It's just the way it is. But if you use the voxel method, then everything is kind of equal in terms of size. So you'll have like a nice distribution of polygons. But yeah, I hope this was helpful in any way.